So this is the question provided by Jeremy IT Lab lecture video. So in the second question, you need to identify the root bridge. How do we identify the root bridge? Identifying the root bridge is going to be simply by comparing the bridge ID of every switch in your LAN topology. And so comparing switch 1 with switch 2, you compare the priority first and the priority ties. So you go to the MAC. Comparing the MAC, switch 1 has a lower MAC than switch 3. So switch 3 will be out. Let's now go to switch 4 and switch 1. Look at the priority first. The priority is smaller than switch 1, so you can switch 1 goes out. You first compare the priority. If priority ties, you compare the MAC address. Now compare the priority of the bridge ID of switch 2, switch 4. Switch 2 loses, switch 4 has a lower priority ID, so switch 4 wins the title of the root bridge. Now after having the after finding the root bridge, you can then assign all of its interfaces as designated. So you have this interface, and this interface are going to be designated. We have designated ports, we have root ports, and designated ports, root ports are in a forwarding state. And so now we can label them as designated. Now what we can then do is to for the remaining switches in the topology, they must have one and only one root port. And so how do we find the root port? Root port is going to be found by finding the lowest root cost on every switch. Now the root cost is the cost of the outgoing interface is the path of the outgoing interface to the root switch, to the root bridge. And so let's go with switch 3, finding the root cost, root port. So we have G01, we have G00. Now G01, in this case, this is a we only count the outgoing interfaces. We don't count the incoming interfaces. So outgoing will be G0 with the cost of 4. So in this interface we have 4. What about G00? So we can have 4 here, and then we have either of them will be having the cost of, this is a fast Ethernet, so fast Ethernet have a cost of 19. And then we can then have them outgoing from G0 or G01. We have 4. Now in total we have 4 plus 4 is going to be 8. 8 plus 19 will be 17. So this has this interface has the cost of 17. Apologies, this has the cost of 27. Clearly, G01 wins the root port. Now let's find the root port on switch 2. Now switch 2 has 4 connections. To find the root cost, you need to find the interface with the lowest root cost. These interfaces will have the root cost of 19 plus 4 plus 4, so which is 27. So we can discard these. These two interfaces have the root cost of 4, because the root cost ties, in this case, you are going to be selecting the interface connected to the lowest port ID. So which interface has the lower port ID? It is it is G00. G00 is connected to this interface, therefore this becomes the root port. Now after finding the root on switch 2, we need to find the root port on switch 1 and switch 1. We do the same process. This has the cost of 8. This here will be 4, and this will be 4, so this has 8. This interface will be having 19 plus 4, which will be 23, so this will be discarded. G01 wins the root port. Now we need to remember that in every collision domain we have one designated port, and so this here is a collision domain. Notice we have a designated port. Notice in here again we have this collision domain, we have a designated port. In this collision domain we have one designated port. Now in here we need to have, so hence we need to have one designated port. Keep this in mind when you have the root port. The root port adjacent to it will be always a designated port, and it must always be a designated port. So this here should become a designated port. Now root adjacent will have a designated, root adjacent designated. So we are fine now. Now what do we do with the remaining connection? So the remaining connections, every connection is a collision domain, and with every collision domain, as mentioned earlier, should have one designated port. So let's examine this connection. Now with this connection, to whom do we give the title of the designated port? We're going to be giving it to the switch with the lowest root cost. So we have the competition is between switch 1 and switch 2. So we have switch 1 root cost will be 4 in this case, and then 4 in here. So this will have the root cost to the bridge of 4. So this has the cost of 4, switch 1 cost of 4. What about switch 2? Now switch 2 has apologies. So switch 1 has the cost of 8. So we have switch 1 cost of 8. Now switch 2 has the root cost of 4. And we have this competition within this connection. So switch 2 clearly wins. So we have the designated port given to switch 2. Alright, so now we have what connections are left. The connection left will be this connection. This connection again, who wins the title of the lowest root cost? It is switch 2. So switch 2 will be given the designated port. So after all, we are left with these interfaces. What do we do with the remaining interfaces? Now with the remaining interfaces, which are connected to a designated port, now this will cut the loop in this connection. This will cut the loop, and so there will be no longer broadcast to storm created within this topology. We have redundancy. However, with the spanning tree, this is the minimum cost in which all switches can reach the bridge, the root bridge. Every switch can reach to the other switch within the network. Switch 1 can reach switch 2, switch 3, switch 4. Switch 4 can reach all of them. Switch 2 can reach all of them, etc. So this here cuts the loop. What do we do with the remaining interfaces? The remaining interfaces will be non-designated. So these interfaces will go with the name of non-designated. And this was all for this question in within Jeremy's IT Lab lecture.